Hey, so good news, bad news in the technology department. I am on my son's computer, which is why I have a different background. I'm just in my kitchen. Through the suggestion of a fellow classmate, found a calculator emulator. So I'm going to show you what I'm talking about. But in other words, I'm not going to be holding my calculator up anymore. I'm going to be able to share the screen, which has the calculator on it. Which is why I have to be on my son's computer because the school computer, it was this whole thing. I was in IT. Anyways, the bad news is he lost the pen to his computer and he's at school right now. So he probably knows where it is, but he's just not here. So I'm going to fake it with the whole pen thing again. But the calculator thing is going to be top notch. Okay. So here we go with discrete probability density functions. So I would say 90% of this is going to be a review video from chapter 3 stuff, but just with different vocabulary and maybe a little different perspective on it, but the concepts will be very similar. And so we're going to start off with a discrete probability density function, and that's what we've been working with. This probability. So you see the two rules, which we have talked about before, is that the probability has to be between 0 and 1. So it's not negative and it's not more than 1. And then the sum of all the probabilities equals 1. So those aren't new rules. It's just a new name for it. So looking at this table, it says number 1, the table below gives a probability density function for discrete random variable x. You'll see that a lot, the discrete random variable x. What is the probability that x is 1? So we can see right here in the middle column that x equals 1 because x is on the top line over here. And so what is the probability? The probability is on the second line. And so for this one right here, see, it's a different program, so that makes these funny shapes. For this one right here, the probability is 0.25. That's it. Uh-oh. That's it, except now I have more shapes going. Okay, probability is 0.25. The probability of 1 is 0.25. Now you might see that written out. Let's see, get my text going. The probability of 1 equals 0.25. That's it. Okay, cool. So now, oh gosh, apparently escape means delete. Haha, isn't it fun learning other people's computers? I feel like if I wasn't like a sort of mess on all of these videos, you would think that it was somebody else making them, right? Like, you gotta have something wrong. Okay, there we go. P of 1 is 1/4, 0.25. So now let's look at number 2. Now I'm going to take a minute to set this up because we're going to use the same problem a few times throughout this video. But we have a pair of fair dice. So that's 2 die, the 6-sided die. There's 2 of them. And you know how it has the dots, 1, 2, 3, 4, 5, 6. Okay. The sum of their faces is recorded. So roll both of them, add up the 2 numbers. The lowest on each die is 1. So 1 plus 1 is 2. So you'll notice the lowest value for x we have is 2. Okay, cool. And then it goes all the way 2, 3, 4. You can think of all the different ways you can make those all the way up to 12 because 12 is the highest number that you could get. 6 plus 6 is 12. Altogether, here's a little backstory. You don't really need to know this, but okay, you might have heard this before. Altogether, there's 36 possibilities. The first one's a 1, the second one's a 2. The first one's a 1, I skip on 1, 1, 1, 2, 1, 3, 1, 4, and all those. It turns out there's 36 altogether. There's only one way to make a 2, and so that's 1 out of 36. There's only one way to make a 12, 6 plus 6. So there's 1 out of 36. Again, you don't really need to know where those come from. You're not going to be creating your own. I just wanted you to know that they did come from somewhere. This wasn't just random numbers in a problem. Okay, what is the probability that the sum of the faces is 4? So I'm going to go to 4. Here, I'm going to highlight it in my little purple box. The probability that the sum of the faces is a 4. Let me get my text going. Oh, there we go. probability that it's a 4 equals 1 out of 12. Now, I would like it better if it was like a 1 and then a line and then a 12 underneath. We're dealing with our limitations here, and this is how I'm able to type, so we're going to just go with it for now. Okay, so 1 out of 12. When you type it in the computer, you'll be able to use the top and bottom thing. Then it says which sum is most likely, which sum is least likely. So the most is going to have the biggest probability. Oops, get my face out of there. And the smallest, the least likely, is going to have the smallest probability. Now, it's kind of hard unless you're an expert at fractions. You might, because they all have different denominators, but I think we can all agree that the least likely is going to be the 1 or the 12, the 2 or the 12. And that's because there's only one way to get those. 1 and 1, 6 and 6. Those are the least likely. The most likely is going to have the biggest fraction. And so as you go in, the fraction is getting bigger. And if we think of this out of over 36, we have 1 over 36. 1/18 is 2 over 36. 1/12 is 3 out of 36. You know, if I just kind of multiply that common denominator, 9 times 4, so 4 out of 36. This one says 5 out of 36. So that means 7 is 6 out of 36, which makes 7 the most likely. If you are like, I didn't get what you just said, I don't know fractions, not a problem. Throw it in your calculator, which is a great time for me to show off my new calculator, right? So let me, I think I need to stop and then come back to this just to make sure you can see it. And so here I have, see how much easier to see? Super shout out for this suggestion. I absolutely love it. Okay, so let me just go back to the main screen. If you wanted to know what are we saying? 1/6 versus 5/36. We can just type in 1/6. See that decimal versus 5/36. And notice over on the right-hand side of the screen, it's showing what buttons I'm pushing. So if I'm going too fast, you can write those down later, or you could just slow down because it is highlighting them on the calculator as well. 5 out of 36. And I can see that 1/6 is bigger. If you've been following along with my favorite button, the N over D button, and you enter your fractions in that way, you could hit that N over D button, which is highlighted in red. Notice the top is flashing. So I hit 1, and then I'm going to go down and hit 6. And that tells me nothing useful, right? It's 1/6. So then we just hit the button right above the enter with the 2 arrows going, wiggling back and forth. And that wiggles right into the decimal. So I can see the decimal is 0.166, 7. So if you are not sure how to compare fractions, don't even worry about that. This is not a class on common denominators. Throw it in your calculator, get the decimals, and compare that way. We will come back to this screen, but right now we need to go back over to our notes. Okay. We will come back to that dice problem. We're going to do more stuff with it. But right now, let's just keep talking about probability density stuff. And so here we have an incomplete probability density function. And it says the number of pets, what should the missing, it tells us the probability. So probability that someone has 0 pets, probability that someone has 1 pet, and so forth. And it's asking for this last box, what is the probability that somebody has 4 pets? Well, in order to do that, we need to first take everything that we have and add it up. So I'm going to add up all of these numbers right here on my calculator. I'm just going to do it on my calculator over here because you don't need to see how to add. And oops, that's not my calculator. I'm going to add 0.72 plus 0.02 plus 0.13 plus 0.11, and I got 0.98. So that total right there was 0.98. Try it again, or slow it down if you need to add them all up to get that number in your calculator. That's not the question though. The question is, what is the missing probability in this bottom box down here? And so what I need to do, because I know for a discrete probability density function, the whole thing needs to add up to 1. So think of this like money. Like I already have 98 cents. What do I need left over to get $1? So the bottom one has to be 0.02 or 2 cents. Well, it's not 2 cents. I'm just using that because it's easy to do in your head. But that's how we get the last number. We add up everything we know and then subtract it from 1. Okay, looking at this next one, we have the following tables. This should be very familiar to you. Different types, decimals, and fractions. And it says, which of the following tables show a valid probability density function? And so what we're going to do here is just look at 2 things. Are there negatives? Or, I mean, technically we don't want things greater than 1 either, but just, real quick, I can see that there's nothing greater than 1. And number 2, we're going to ask, do they add up to 1? And so definitely take your time. I'm going to go through these kind of fast. Oh, no, I'm not. What I'm going to do is I'm going to pause it, and I'm just going to kind of throw up the answers here in a minute. And so what I want you to do is just pause it, look at all of these problems right here. And then when in a second, I'm going to unpause it, and then I will have all of, what am I trying to say? What am I going to have? I'm going to have all of the answers up for you. Okay, yes, that's what I'm going to do. Pause. Okay, so I have done all the problems. So I have all the answers up. Hopefully you've paused it. If not, last chance, pause it. Do the problem, number 4. And then I'm going to put the answer up right now. Okay, so this is what you should have for that problem. You should have those 3 are not valid probability functions. The other 3 are. The ones I didn't cross out are. So let's see, why are they not valid? Well, this first one up here, it's going to be more than 1. If you add all those 3 numbers up, the 0.74, just think of it money, 74 cents plus 54 cents, that's more than $1. Doesn't work. This guy over here on the bottom right has a negative. So that's no good. And then the middle bottom row, that one turned out to be less than 1. When you add them all up, it was less than 1. So it has to equal 1 when you add them all up, and no negatives, nothing greater than 1. Okay, not too terrible. The last thing, well, these last 2 are the same basic idea. This last concept I want to talk about before we go back to the dice problem is combining probabilities. And so here we have a list of all the probabilities for whatever this number of extra credit problems someone can receive. And so what we're going to do is we're going to add the probability of 1 plus the probability of where'd it go? Oh goodness, I stopped typing for some reason. Probability of 1 plus the probability of 2 plus the probability of 4. Okay, so we're going to add those 3 fractions up. Again, I'm going to write terrible fractions because I'm typing them instead of writing them out. But we have 1 out of 20 plus 7 out of 20 plus 1 out of 10. And I'm going to jump over to my calculator so that we can see what that is. And I'm going to forget what I wrote. So I'm just going to take a quick picture on my phone so I can look at it when I switch screens. Okay, so I'm going to switch back to my calculator. I'll have fractions written right this time because I can do it with this little N over D button. All right, so this way, some of you might be like, I'm fast forwarding because I already know, because it's not that terrible of denominators. That's fine. Other people are like, nope, I don't add fractions. I want a calculator. That's fine too. So I'm going to hit 1 over 20. And then if I hit plus, see how it's flashing in the denominator? I don't want to hit plus. So I'm going to hit over plus. And now I'm going to do my fraction again. 7/20. Hit the over button again to get out of the denominator. And the last one was, oops, get my plus. Fraction 1/10. Ooh, what did I do? Try it again. Fraction 1/10. Enter. Now I asked it a fraction question, so it'll give me a fraction answer, and I get 1/2 as my final answer for this problem. So I'm going to switch over. Oops, for some reason, Michael's keeps texting me. Okay, so I am going to switch over back to the notes. We said it was 1/2. So I'm going to say equals 1/2. Again, calculator optional. Some of you can do that in your head. That's fine. Okay, this last one here, same idea. We're going to just look at different things kind of around this 3. We're going to do stuff bigger than and less than, but it's kind of all around the 3 right here. Oopsies. Let me get rid of that. So the first one is less than 3. So that's going to be this section. Gotta love my mouse circle skills. Okay, less than 3 would be those numbers right there. And so we have the probability of less than 3 is going to be 1/8 plus 3/16 plus 3/8. So we're going to add all those together. We're going to get 8, 9, 10, 11 16ths as our final answer. We already showed you how to do the calculator. So if you want to pause it and go throw it in the calculator, by all means, go ahead and do that. Then we want to know the probability greater than 3. So that would be the greater than 3. So again, we're not including 3 in this one either, because greater than 3 means more than 3, not equal to 3. So I'm going to say 1/8 plus 1/8, and that's 2/8, which reduces to 1/4. And then our last one is the probability of 3. And I didn't write the first part on, I'll go back and write those, but the probability of 3 is 1/16. So I've been writing like the probability of 1, the probability of 2, but I didn't write these other ones, and I don't know why, I just forgot. But the way we would write it is we would say the probability that x is less than 3 equals, and then it would have the fraction right there. And then down here, I would say very similarly. So I can have an inequality, I can have an equal sign, probability that x is greater than 3 equals, and then there's my fraction right there. So it doesn't just have to be a single number in there. It can be that. Sometimes people write probability and then they write 0, 1, 2. It kind of just depends on what you feel comfortable with. Okay, let's move away from probability, and we're going to move over to using the calculator a lot more. And so we're going to talk about expected value or mean of a discrete random variable. Before we get into that, look here, we have the same problem that we were doing before with the dice. And so we already know, what do we know? We just know which one occurred the most and which one occurred the least. Okay. But what we want to do is we want to find the expected value. So like, what do you expect? What it says mean is another word for it, because it's kind of like, what's the average that you would get if you did this like a whole bunch of times? Like which one would show up the most, kind of thing. And so the way we're going to do that, there's 2 steps. We're going to multiply each value x by its probability. We're going to multiply every single row by like 2 times 1/6. 3 times 1/18th, and so forth. And then we're going to add that all up together, and this sum is the mean. Okay, and we're going to use the Greek letter mu. So this is pronounced mu. It's fun to say. Okay, so that's what we want to do, and we want to find the mean or the expected value of this whole list. Now, we've talked about frequency tables before and histograms and whatnot, and we found the means of those. However, those were whole numbers because if you have the towers of the histogram or the tally marks, those were always whole numbers. And now we have fractions because we're doing probability. And so what we're going to do to find mu is we are going to multiply everything. So 2 times 1 over 36 plus 3 times 1 over 18 plus 4, and this is going to take a minute because there's a lot of them, 1 over 12 plus 5 times 1 over 9 plus 6 times 5 over 36 plus 7 times 1 over 6 plus 8 times 5 over 36. Almost there. Plus 9 times 1 over 9. Oh, that's easy. That's 1. Plus 10 times 1 over 12. Plus 11 times 1 over 18. Plus 12 times 1 over 36. Oh man, can I stretch that out? Oh, I was so close. Okay, that should go over there. If I take, okay, I took off the last parenthesis. Okay, what does that equal? Put it in your calculator, right? That's the only way you're going to do this is to throw the whole thing in your calculator. I wrote out the whole thing right now because it's just easier, right? Like you want to have this for your notes for the next test. Let's have it all written out for the first time. But as you're going, you just type that whole long thing in your calculator. So go ahead, type it in your calculator. I'm going to give you a second. And then once you do that, you're going to throw that. What am I trying to say? You're going to throw that in your calculator. I'm going to come back. I'm going to have the answer for you. And you're going to agree because you put it in your calculator and you're not just copying with me, right? Okay. Brief pause. Okay. So the answer that you should have is 7. Mu equals 7. Now, of course, you're doing the mu. I just don't know if I could do it with my mouse. Mu equals 7. Okay. Maybe you're like, okay, well, isn't that the middle number anyways? Isn't that the one that we said was the most? Okay, yeah, but did you see that ahead of time, or are you looking at the answer and then kind of figuring it out? And also, it's not always like that, right? You can't always, like sometimes the numbers are just too wacky that you can't make up rules like that. So we don't want to make up a rule. We want to calculate it. We multiply X times the probability. And then step 2 is to add them all up. And that is our mean. That is our expected value. Okay, so let's try that again. There's like such an easier way. I will show it to you. Let's just get through this and then I'll show you on the last page. Okay. In a game, participants spin a wheel to win a prize. The wheel is split into 10 sections. So you've seen this like at the fair or whatever, you like spin it, or if you go to like any sort of festival, not festival, but like health fair kind of thing. They always have those wheels where you can get prizes. And this one has 10 sections. And I've never seen a festival that gave me $800. But anyway, 6 of the wedges show $0. 2 show $100. 1 shows $300 and 1 shows $800. So we want to find the mean of X. We want to find the expected value or mean of this problem. So what we need to do is write out all the things with the probability. Now, there's 10 sections. 6 out of 10 of those sections pay me $0. Oops. Oh gosh. Oh no, what did I zoom? 6 of those sections gave me $0. Where was I? My goodness. Okay. We're just going to hit Control Z. Haha. Okay, start fresh. 6 out of 10, that's the probability, gives me $0. That's the value. Okay. 2 wedges, so 2 out of 10, why am I yelling? 2 out of 10 gives me $100. 1 out of 10, one of the wedges gives me $300. And finally, 1 out of 10, that last wedge, I don't know, I don't like it down there. I'm gonna just make a new line. 1 out of 10 will give me $800. Okay, so I can go ahead and put that all into my calculator. Now I don't need to do 6 out of 10 times 0, right? Like that's just 0. But if I put the rest in my calculator, 2/10 times 100 plus 1/10 times 300 plus 1/10 times 800, just type all that into your calculator, and we get $130. So the mean of X equals $130. So probability times whatever we're talking about. So in the previous problem, we were talking about the sum of the dice. X was the sum. It was 2, it was 3, it was 4. We multiplied those numbers times the probability. In this problem, we had the probability. So 6 out of 10 wedges gave me a 0. 2 of the 10 wedges gave me 100. 1 out of 10 wedges was 300. And then finally, 1 out of 10 wedges was 800. So it's the probability times the amount. And you just multiply probability times the amount for everything, add it all up, and then that will give you the final answer. Okay, last one, going back to the dice. We want to find the standard deviation. So expected value means mean. And then where there's mean, there's standard deviation. So here we go. We have a pair of Faraday. Remember this problem? We just did it like 5 seconds ago. It says the expected value is 7. Ooh, that's what we got for number 1. So we're good. We're on the right track. Okay, the expected value is 7. Now, what we want to do is calculate this table. Oh, I scrolled past the instructions. So here's the instructions. We want to find the deviation, the difference between the data value and the mean. So we know the mean is 7. So we'll put a pin in it. We're going to do that first. Just that one step. Okay, so this first one is 2 minus 7, which is -5. So X is 2. That's what it says on the top. 7 is our mean that we calculated earlier, and I also highlighted it right here. So I'll do that one more time, and then I'll just put in the actual answer here. Oopsies, I don't like that. Let me try that again. This next one, we have 3 minus 7 equals -4. And so we're just going to keep going. 4, I won't write them all out, but I'll just write the answer. 4 minus 7. And then we have 5 minus 7. And then we have 6 minus, and we're getting a lot of negatives. That's okay. 6 minus 7. 7 minus 7 is 0. 8 minus 7 is now a positive. See, we're like on the other side of 7 now, so we're getting different answers. I don't know why this is moving. Sorry if you are getting seasick. 9 minus 7. 10 minus 7. 11 minus 7. Oh my gosh, just go. And finally, 12 minus 7 is 5. Okay. Easy peasy. Just subtract the number in the X minus the mean. In this case, oh gosh, my battery's running low. In this case, it was 7. Let me just find a new plug. Pretty sure my outlets don't quite work in my kitchen. Okay, so this is what we're gonna do. I'm gonna pause it. You're gonna fill in the next one with the